Hi everyone, my name is Andrew. I lead the cloud and product security team at Seek. Welcome to our session today on streamlining security investigations with Amazon Security Lake. I'm joined today by two of my colleagues here. Priya is our security engineer, and Ben, our threat hunting manager. I'd like to begin also by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past, present. All right, for our session today, I'm going to start talking about the challenges of security data management and how we're thinking about that at Seek. Priya will then talk about some of the more of the details of our architecture. And for the last half, Ben is going to do a demo of a threat hunting scenario using Security Lake, which is really cool. All right, so a bit of a background on Seek. You may have already used Seek in the past to search and apply for jobs yourself, or even used us to hire people for your own organization. Seek is the leading online employment marketplace across Australia, New Zealand, and Southeast Asia. And across all of our brands, we have relationships with about 60 million candidates, nearly 500,000 hirers, and we operate in a marketplace that covers a population of nearly 1 billion people. And in order to help all of our customers find jobs and hire people, we typically serve up around about 50 million searches a day on our website. So we have a large operational footprint in the cloud, and as of today, virtually all of our production workloads are running on AWS. As a business that has this much data and has a large operational footprint, and of course, one that cares a lot about the security of our customer data and the systems on which that runs, we really need to address some of the challenges around security data management. And so what I'd like to talk about first is what is the ever-increasing volume of log data that we as security teams need to deal with today. That's further compounded by the growing number and sophistication of security tools in the market. And those tools are always generating loads and loads of logging and event data. That then leads into the next challenge, which is we have all this data and all these tools, and what that tends to do is drive us towards a situation where we end up with loads of different applications and systems that we need to support to work on this data. And that adds also to fragmentation of our data management. An example for us is we used to have one way of dealing with VPC flow logs, and another way to handle our CloudTrail logs, and yet another one in how we would deal with, say, our EDR logging. So this fragmentation kind of then can lead to operational overheads where you're having to deal with multiple solutions and systems all the time, and that can be operationally and cost-wise very inefficient. So what we want to do is really focus on getting the best out of our investments and try and make our processes as efficient as possible. And the last one I wanted to point out here is the lack of standards and standardization today over our data. There's a real loss of opportunity, I think, here to leverage all the value that we have in our data. Things like automation and monitoring and analytics just become simpler and easier. And hopefully we'll also show new opportunities emerge through things like a threat hunting capability. So, a bit of a background here. About 18 months ago, we had reached a point where we had to re-look at our strategy around security data management. And we very quickly realized that we needed to actually apply some engineering effort to solve this problem. So we started to work with our data science team to design an in-house security lake. Now, from that exercise, it became obvious that we had identified a bunch of security and business needs. And the first one here is around separation of concerns as a core architecture principle. What we wanted is something that was modular and flexible that allowed us clear abstractions over data ingestion, query, and storage, and allowed us also to leverage data formats like Parquet. There was also another benefit that we sort of came to realize, that it would allow us to deliver value to the business incrementally over time and not in just one big bang at the end. So the second one here goes back to, when talking about the volume of log data, is performance. We had situations where our query performance, or we struggled with query performance across certain data sets and to certain types of queries. And from a security investigation point of view, especially those that are time critical, that can have quite an impact. Another thing was improved operational efficiencies. We needed to lower the total cost of ownership through not having to manage as many disparate and separate systems all the time, working on the data. And finally, we'd also identified that there was an opportunity to build a foundation on which the capabilities of this platform were extensible and reusable. And so Priya will kind of expand on that a little bit in a bit. Now, before we'd actually gotten too far with our own internal implementation, back in 2022 at reInvent, AWS announced the launch of Amazon Security Lake. And so this was really timely for us because we very quickly realized that the problems that Security Lake was solving were all the same things we were already designing for. So features and capabilities like automatic centralization of security data from cloud and on-prem and other custom sources into a centralized security lake that's all managed in your own account. It also streams all that data in a format, a standardized format in Parquet, query efficient, all backed off S3. You have full control over all the data lifecycle and the data. And most critically, it normalizes all this data into Open Cybersecurity Schema Framework, or OCSF. That means now we have all our data in one location, and all of those data sources are all standardized and normalized to the one schema format. And finally, they're going back to the modular design concept. Security Lake also allows you to plug in all these different analytic tools to operate over all of this data. So that's a very high level of how we've been thinking about Security Lake and security data management at Seek. I'd like to now hand it over to Priya, who will talk in more detail about our approach and the architecture.
Thanks for that, Andrew. So what you see here is our Security Lake solution at Seek. So what you see for log sources, we are ingesting AWS native log sources, such as Cloud12, VPC flow logs, DNS logs, and Security Hub findings. For custom sources, we have AWS partner integrations with Carbon Black, CrowdStrike, Tenable, and Netscope, where we are ingesting device and endpoint logs. Under the hood, Security Lake is processing and normalizing these logs to OCSF format and then storing them to S3. Now, for the subscriber, we started off with Amazon Athena, which was provided straight out of the box by Security Lake. So this was quite interesting and useful because our team, who are already familiar with Amazon Athena and SQL queries, were able to start leveraging the security lake as soon as it came out. With Splunk, we are currently doing, exploring actually, additional benefits we can derive from a point of detection and investigation capabilities. And the last one is the vulnerability management platform as a subscriber. This is an unexpected use case which surprised us the most. Vulnerability management platform is an in-house project built at Seek to surface vulnerabilities across our ecosystem. One of our goals last year was to surface host vulnerabilities, specifically on AWS ecosystem. Initially, we started off with a design in mind to integrate directly with Security Hub, where these inspector findings were aggregated. However, during the same time, we were doing our exploratory work with Security Lake and discovered that the Security Lake already had these inspector findings we needed. So fast forward, today in production, our platform is making daily queries to Security Lake and pulling these host vulnerabilities. So with Security Lake so far, we had few amazing wins. Definitely one of the wins is now we have a centralized security data lake with AWS and external sources in one central location. Moreover, it's all in OCSF format, that is all the logs are in one standard format. We were also able to ingest custom lists such as threat lists, indicators of compromise, and similar into the same lake. With this now, this meant that our team was able to correlate multiple log sources with ease, and they didn't shuffle between systems to do investigations. On the same parallel run, we saw that the investigation speeds were faster because the query speed was pretty good. We observed close to 20 to 30% improved performance depending on the complexity of the scan and the scan volume. Then, as I mentioned before, the vulnerability management platform as a subscriber was an unexpected and a surprising good win. So overall, it has become quite clear to us during this journey that with Security Lake, we now had better log visibility and also faster, efficient investigations. So beyond these quick wins, now we have started exploring traditional capabilities such as incident response. We also started looking into capabilities around threat hunting and detection, attack path mapping, and identifying high-risk user behaviors. As you see, we started now pivoting from reactive security use cases like incident response to proactive security use cases like threat hunting and detection. Beyond this, we also see ourselves expanding into reporting and metrics area where we are looking at, which is very critical for business and security outcomes, similar to what we have done with vulnerability management platform. The last one, which is again a great realization we had, is Security Lake doesn't need to be for security use cases alone. Security can also be expanded to wider engineering groups for domains such as cloud operations, where they can even leverage this data for DNS investigations or network investigations. Now, I would like to hand over to Ben to talk how he and his team are leveraging Security Lake to generate insights and uncover potential threats. Cheers.
Thanks, Priya.
I'll just sit here.
So phase 2 threat hunting, effectively what we're doing in this phase was really trying to look at ways we could exploit or utilize Security Lake a little bit more within the proactive threat detection space. And Andrew's alluded to previously, we've had some luck with citing indicators of compromise within Security Lake. But what we wanted to do was really move beyond just using ISCs for threat hunting. So we really took a bit of a step back and had a look at the sort of the core objectives that we wanted to achieve with threat hunting. And one of those was really trying to lower the barrier to have others outside the security operations space actually come in and contribute and participate in threat hunts. So with that, we really wanted to try and leverage some of the subject matter expertise or domain knowledge from other people outside of our space. So thinking like security software engineer, for example, someone who's working on a project or a program of work that's really outside of our scope, and then being able to come in and actively contribute to that threat hunt. But one of the things that we perceived as an issue, and we found as a bit of an issue, was that barrier to entry. So it was pretty complex and pretty taxing, to say the least. So for them to actually come in, there's usually 4 or 5 different tools. You've got endpoint, you've got log consolidation, networking, gateways, and all of those have different query languages. All of them have different data dictionaries, and there's all different documentation as well. And then you've also got the documentation on the tradecraft, the actual approach to the hunt. So getting a security software engineer to actually come in and participate when they've got limited time, something that's time boxed, is definitely a challenge. So what we're looking at is trying to consolidate all that and effectively try and build out a single pane of glass type playbook. And I guess this is where SageMaker came in, and really the Jupyter Lab, Jupyter Notebook capability, sort of having that ability to have everything sort of consolidated into that one place, and they could actually come in and then feed and pivot into that. So what I'm going to do today is do a demonstration of a threat hunting notebook, and obviously going to be using a Jupyter Notebook for that. So for those that aren't aware of what a Jupyter Notebook is, it's a portable document format that's based on JSON, and it can contain Markdown. So effectively you can have headings, you can have different sized text, you can have images, graphics, you can have reference links going out to third-party websites as well. So you can have some really quality documentation there. But the really appealing thing from our side is the ability that it can actually contain code, and as long as it's configured correctly and pointing to the right system, you can execute that code and then bring the results back into that document. So that was pretty appealing, and it's something that we've been playing around for a little while, but on a much smaller scale. So we've been using effectively notebooks on laptops or individual Docker instances, but the issue with that was really trying to scale out and have other people come in. So it really wasn't scalable, and that's where SageMaker came in, and that really piqued our interest. So the notebook I'm going to focus on today, it's going to be focusing on a tool called Cobalt Strike. So you may have heard of it, you may have not, but it's effectively an enterprise level red teaming pen testing tool. Really capable. And for that reason, it's prolifically used by malicious threat actors around the world. So it's used for good, and it's also used for not so good purposes. Within the notebook, we're going to have some detections, or what we call hunt analytics, and they're going to be based on Sigma rules. So Sigma rules are an open source type rule used for detections. They're based on YAML and predominantly used for log sources. So stuff like Splunk, Windows event logs, that sort of thing. And with the hunt analytics, we're going to be focusing on what are called TTPs, or tactics, techniques, and procedures, and predominantly focusing in on techniques. But to give a bit of context around what they are, it's how the adversary will go about achieving their objectives. So focusing on TTPs, and to give a bit of context around TTPs, you can see a pyramid on the screen. That's called the Pyramid of Pain. And that was developed in 2013 by an individual called David Bianco. So he's contributed a lot to the security community over the years. And what he was trying to articulate with the Pyramid of Pain was basically the different types of detections that can be put in place, and the amount of frustration it's going to cause the adversary once they're found. So for example, we've got like IP address there. So if you've got some intel that's come in and you build a detection, it triggers, you find it, and you put in place some sort of mitigation to block it. For the adversary, that's going to be pretty trivial for them to actually change up that IP address. So if it's hosting something like a second stage downloader, and they've got some pretty good operations on their side of the fence, for them to change that up, it's going to take a matter of minutes. But if you're focusing at the top of that pyramid, you're focusing on, say, techniques, something like DNS tunneling, it's not going to matter what tool they're using. It's really going to frustrate them. So you're really, really disrupting their tradecraft. And at the end of the day, they're going to go try to find someone else with low-hanging fruit, or effectively throw the toys out of the pram. So what we're going to go to next is just how we've got the notebook environment set up for the demonstration. So what we've got is obviously Security Lake. We've got some logs that we're pulling in there. So we've got some endpoint logs, and for those ones we're using Carbon Black. So if anyone's interested in how we got those into Security Lake, definitely hit me up after this. I'm more than happy to have a chat about it and let you know what we did. We've also got some network telemetry and DNS logs as well. So we're obviously using Security Lake. We've got SageMaker, and within that, we're using Jupyter Notebook functionality. And within that Jupyter Notebook, we're going to be using Athena to run those SQL queries going back into Security Lake and pulling those results back into that notebook document. So now I'll kick off the demo. And as always, we'll start within the AWS console, and we'll go to SageMaker. From there, we've got a pre-configured domain, and we'll go in there. We've got a pre-configured user profile in there. So we'll go to SageMaker Studio, sorry, and then we'll go to the Jupyter Lab component. From there, we've got some pre-configured labs, so we'll go into the lab environment where we've got our notebook environment. So here we've got the Cobalt Strike notebook. We've got some some setup files here, sorry. So we've got a setup.txt and a setup notebook. So what they do is effectively just do some configuration with pulling in libraries and setting some environment settings. So just put yourself in the situation of being like a security software engineer coming in to participate in a hunt. So first off, what you've got is some pretty descriptive text around what Cobalt Strike is, so it gives you a bit of an overview. And then below that, we've got some reference links. So we've got some links there that go out to the vendor website and around the techniques. Then below that, underneath initial setup, what we've got is the code blocks. So there's a few different ways that we can run these code blocks. You can highlight it and then just run that individual code block. You can run everything above it, everything below it, or you can run actually all the code within that document and have it execute at once. So just back to that initial setup code. So what we've got there is basically just some variables and some settings for this particular notebook. So we're just setting up some additional libraries. We've got a definition around the table that we want to start off in, and then we've also got a function there to support the SQL queries. So now onto the Hunt Analytics. So what we'll do first is just kick off and run all the code in the notebook so we get some of the results back in. But onto the first one. So this first one, it's focusing on some C2 observations or trying to cite those. We've got some reference links there. So we've got the sigma rule, and effectively what we've done is ported across some of those strings into the SQL query, and then they get run against the Security Lake tables. So then what will happen, those results will actually get brought back in. You can see underneath there, we've got some that are blurred out, but we've got some results that have come back. So for the second one, it's pretty similar. So what we've got is, again, some more granular documentation around this Hunt Analytics. So this one's focusing on name pipes. We've got some MITRE reference material on the technique. And then again, we've also got the sigma rule. So what we've done is access the publicly available sigma rule. We've ported across the particular strings that we're looking for, and they've been brought across into that query. They've been executed. And again, we've got those results sitting at the bottom underneath that query. So onto the third one. The first thing I'll draw your attention to is just the line of red text there. So what that is, that's just moving to a different table. So what we'd be doing if we weren't using the notebook setup would actually have to be pivoting between different tools to run these queries. So effectively, we've got this single pane of glass. Again, we've got the sigma rule that's been ported across into SQL and then run via Athena, and brings those results back into the notebook. So again, we've got that sort of single pane of glass approach, and we're on to the next one. So the final one, for this one, we're not using a sigma rule. So this one is basically just focusing on a particular technique, and this technique is DNS tunneling. So it's not unique to Cobalt Strike. It can be done within a few different tools, but effectively, it's a good example of the top of that pyramid and using a technique within that TTP. So I guess the main thing I want to try and highlight with the notebook is not the Hunt Analytics themselves, but effectively having that single pane of glass. So trying to consolidate what we'd be doing with multiple tools, multiple documents, and different systems to try and capture everything. And really trying to take the approach where I suppose a data scientist would, using SageMaker, where they'd actually capture some of that subject matter expertise and then have others come in, such as data engineers or data analysts, pivot off that and then feed into it. So it's really trying to take, I guess, more of a system-based approach, and really trying to leverage other people to act as a bit of a force multiplier, where you'd have more of a bottleneck around that technical expertise with threat hunters within the team. So for us at Seek, we've definitely got a little bit more work on the horizon with Security Lake. We definitely want to try and bring in some more technical telemetry sources. We've also been focusing on intel, particularly threat intel ingestion, and definitely doing a bit of work in that space, and hopefully we'll be able to present on that in the near future. But the other side of intel as well is the business side. So we're looking at how we can bring in information around critical business services, critical business risks, and hopefully leverage that to then focus our areas where we do the work. So making sure we're focusing on the most important stuff to the business. And then the last bit that we have been working on and definitely want to explore a lot more is around the subscriber side. So Andrew alluded to the work he's been doing with the vulnerability management platform. And from my side, from the threat detection side, we've been doing work with some security search head tools, so stuff like Splunk, Elastic, Datadog, where we can potentially leverage the commodity detections and the high quality detections they produce, having that sort of plug into Security Lake and then effectively have it as a sort of module. And if there isn't any performance or we don't have any luck with those, then we can just unplug them and throw the next one in. So that's really the beauty of having that OCSF format and other vendors there that are effectively supporting it as well. So I guess today what we've done is effectively presented on what could be called our first iteration of a security data management platform, and obviously Security Lake is the foundation of that. We've been quite fortunate in our approach in that we haven't been constrained to deliver into a certain program within a 6-month window, for example, or have to deliver it by a certain budget by a certain time. We've taken sort of a slow, iterative approach in fleshing out the use cases that we've discovered and then showcasing them. So it's been quite exciting from my perspective. So we did very early on initial design with our data services team, then Security Lake came on. And then we started to look at how we could use that for threat detection, and Andrew and his team really were quite supportive and were able to help us out. But organically from that process, they identified that they could then use it for their vulnerability management platform. And I think that's a pretty common theme with what we'll be moving forward with, and other teams being able to leverage Security Lake in a similar manner. And I think the key thing for that is the fact that it's got a open data format with OCSF, and then the ability to plug in additional tools that other vendors are coming on board with. So I think having that is going to be really a key to success moving forward. So that brings me to the end of the presentation, but look, if you are interested in pursuing Security Lake more or doing some proof of concept work or playing around with it, definitely check out the QR codes on the screen. And in the same theme, if you are interested in doing some self-development or upgrading some skills in anything we've talked about today or anything at the conference, then again, sorry about that. Then again, check out AWS Skill Builder. So that's it from us, but look, if you've got any questions, we'll be around for the lunch break, so feel free to come up and have a chat to us. We're more than happy to go into a bit more detail. And always at the conference, if you do have the app, we'd really appreciate if you could provide some feedback so we can improve it for next time. Thanks very much.